So a lot of people are worried about quantum computers and decrypting stuff. And the worry is that quantum computers can do a lot of stuff so much faster than normal computers. So much faster. In theory, we're not close to that by any means, but you never know when there's breakthrough, which is also something hard to predict. And there's a bunch of reasons why they can do that. A classical computer only has on-off. A quantum computer can easily have 8 different stages. So that means with 2 things, instead of being 2 times 2, you have 4 for a classical computer, but quantum computer can have 8 times 8, 16. 64. Why did I say? And it keeps going up faster and faster and faster. Quantum computers can also do quantum annealing, which they can use, explore a lot more areas, and you have to write your programs more specifically there. So you have the qubit annealing. They can also transmit information between different parts of the chip a lot faster than transistors and electricity, actually instantaneously. They could have smaller things at the size of an atom doing computations instead of thousands to millions to billions of atoms, and a lot of other things. And then if you're the only country with a quantum supercomputer, you could break up all these encryptions, and we figure out ways of doing it a lot faster. However, to some extent, you can also just make the encryptions more complicated with a quantum computer using classical ones. And if we use that one, it gets hard to decrypt. Decrypt. But there is a way with a lot of these ones that there actually is a kind of a boundary where the encryption start catching up, and during the initial rollout, people will not all be using quantum computers. So that's always there, and it's still valid. Another thing is I've discussed about using neural networks to make a whole language for it, and other ways with privacy. And languages you can't decode. This is why the Navajo code talkers were so effective in World War II, is because they were speaking a whole language, so there wasn't a pattern that was easily recognizable as English or something. They just have to switch around letters. But another thing is there's also quantum encryption, and quantum encryption theoretically is the most secure encryption that we know of. And instead, if we use this quantum encryption, at the same rate we're boosting up all these other technologies that can decrypt better, they could cancel out very much. And what we're left is with a safer, maybe even a safer one, because quantum encryption is so good, and quantum supercomputers cannot keep up with that. So where should we put the money? I think maybe we should put the money and funding more to quantum encryption for this very reason. And quantum encryption, I think, is in some ways a lower hanging fruit than quantum supercomputers. It also could lead, quantum encryption is based on technology sending beams of information using quantum mechanics, which could send information instantaneously, not even the speed of light, instantaneously under ideal conditions, which would mean the fastest Wi-Fi possible. You still have the problems with routing and everything, so it ends up getting the right place, so there is slowdown there. But that's a struggle, and I think that's something to really look into. Quantum encryption does not necessarily rely on supercooled computers and everything. In Law's vacuum machine instead of quantum other one, it does have its own challenges, mainly that it has also delicate states, just not as delicate. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. But with your help, I think I can do it. Thank you very much. Goodbye.